Hello and welcome back to PaleoCast. I'm Dave Marshall.
And I'm Liz Martin.
So Liz, this is another episode of yours, and this one is on the Blue Beach fossil site. Is this because of the newly described horseshoe crab Paleolimulus woodea from that locality?
No, it's not. This is actually something that I have wanted to do for a little while, looking at some of the vertebrates, not the horseshoe crabs.
Oh. Well, I'm sorry, audience. You might as well switch off now.
Yeah. No, we're talking about much cooler things than horseshoe crabs. Sorry.
So when did you first become aware of Blue Beach?
I've kind of known of it for a little while. Being Canadian, you hear about a lot of the sites, but I didn't actually know about its importance until maybe a few months ago or a year ago. Mm-hmm. Somebody actually suggested an episode on it on Twitter, and I kind of thought, oh, that's interesting. And then I looked into it and went, oh, that's actually really interesting. We should do that.
Yeah, so we do take interview requests, so ask away, you never know. Sometimes you might just hear it. And how did you get to know Jason Anderson, Professor Jason Anderson? How did you know he was the guy to call?
So I met Jason last year at the Canadian Society of Vertebrate Paleo meeting, which I've only been to once, and that was last year. So I met him first there. And I started looking into Blue Beach and wanted to talk to somebody who had published on specifically the tetrapods, and noticed that he had published a paper last year on the Blue Beach tetrapods, and thought, well, that's perfect. Since I know Jason, that would be a great person to talk to.
There's a lot of tetrapod localities, though. So why this one in particular? What's so special about Blue Beach?
So Blue Beach is important for the specific age that it is. So there's only a handful of places all around the world at this specific age. And that's kind of the importance. But of course, we talk more about why it's so significant in the interview.
Well, before we get into the interview, there's a few admin bits and pieces to sort out, so this is going to take a minute. If you want to skip over that, I don't blame you. First of all, the PaleoCast art competition is still running until the end of the month. We've had a load of entries, so please have a look at them all on our Facebook and Twitter pages, and like the images you like, favourite your favourites, and the images with the most votes by the end is the winner. And then we've also got some other categories as well. So please share images and to get them more votes, and all the votes count, even if they're not on the original post. We can still keep track of them all, just so long as your privacy settings allow it. Next up, we're sorry that we couldn't bring you the EAVP conference live, so sorry for any disappointment with that. We had some more internet connection problems that we couldn't get around, so it's nobody's fault, but it's still disappointing. But fear not, we are currently prepping all the videos for release. So it's a whole other conference, and this is a 3-day conference. So there's plenty of videos that you'll be able to watch back at your leisure. And it's got a fantastic symposium on the legality of fossil collecting that you don't want to miss. Next up, the Virtual Natural History Museum is proceeding nicely, and we'll be in touch with the details of our rewards for all the backers. If you feel you've missed out, fear not. The crowdfunding campaign is still open, so feel free to donate all of your life savings to that. There are still some great rewards to bag. And speaking of money, you can always donate to the show itself on our homepage, and thanks to all those who have done so far. We really don't thank you enough, so we hope you especially enjoy this episode.
And as usual, we have a number of very beautiful images to go along with this episode, courtesy of Jason and the Blue Beach Fossil Museum. So make sure you check it out, and don't forget to share this interview and this episode on Facebook, Twitter, and everywhere. And I hope you like it. So today I am at the International Congress of Vertebrate Morphology, and I'm joined by Associate Professor Jason Anderson from the University of Calgary. Thanks for joining me today, Jason.
Well, thanks for having me.
And why don't you introduce yourself a little bit and talk about how you got into paleontology and into this field?
Well, I am from Western Michigan, and as a kid growing up, I used to go fairly regularly to Chicago, see the Cubs, but also to the Field Museum of Natural History. And I was always struck by the giant room full of bones that they used to have. Mm-hmm. And I think they should go back to, Ken, if you're listening to this. But apparently, even as a kid at about 4 or 5, I was running around from dinosaur to dinosaur, and I apparently ran up to a security guard and said that someday I was going to work there. And it actually has come true. I was able to do some research with John Bolt there on numerous occasions. So I've always been interested in paleontology, but like most people, I grew out of it for a while and actually originally went to school to go into acting. But realized fairly early on that I didn't really have that passion and drive that's necessary to succeed in acting like some of my cohort had, and it was very clear that they had that. So I, after my first year of university, took 5 years off and worked while I figured out where I had that kind of focus and passion for, and realized that those old dreams of running around looking at dinosaurs was really where my interests were. So that brought me back to paleontology. And I finished my degree, undergraduate degree at University of Michigan, which has, of course, a fantastic paleontology program, and then went on to McGill University, where I did my PhD on amphibians, not dinosaurs, with Bob Carroll. And then after postdoc at University of Toronto with Robert Rice, got my first job in Southern California, which led to my second job and current job at the University of Calgary.
Very cool. So most of the work that you do, as you said, you worked on amphibians. You don't actually do a lot of work on dinosaurs themselves.
Yeah. So
how did you sort of get interested in sort of early amphibian, that kind of evolution? How did you start that?
Well, it was quite literally Bob Carroll offered me a series of projects that he had sort of ready to go for students to take on. One was Pleurosaurs, so aquatic relatives of the Tuatara. One was working on the fossils of Blue Beach, and one was working on a group of lepispondal amphibians known as Ichthyostega. And so I looked at each of these 3 projects and decided that the Ichthyostega project was the one that I would have the greatest impact and the greatest likelihood for success. And that's what I went with, which is sort of ironic because here we are talking about Blue Beach.
Yeah.
So that and I mean, issues related to dinosaurs and amphibians translate. Anatomy and morphology is the same, and the methodology is the same. So, although I did my undergraduate research project on ceratopsians, transitioning into amphibians was actually quite easy, quite natural.
So where did Blue Beach come into it then?
Well, Blue Beach was a locality that Bob and his fellow graduate students at Harvard, including Don Baird, had worked since the 1950s on and off. I mean, it's a really fascinating locality with a very long, rich history going back to the founding father of modern geology, Charles Lyell, knew of this locality. It was best known as a footprint locality. It's a beautiful stretch of about a mile-long beach along the Avon River, north of Windsor, Nova Scotia, which is about an hour north of Halifax, on the Bay of Fundy. And because of the world record tides in the Bay of Fundy, there's enormous amounts of erosion, but it's a beautifully exposed sequence of rocks, and that has attracted geologists for many years. And geologists have found numerous footprint traces through the various deposits at Blue Beach. As well, there are different deposits preserving things like mud cracks, preserving old forests, lepidodendron stands. You can see where all the trunks of all of these trees used to stand. It's fascinating. But Don Baird and Bob Carroll went there looking for vertebrate bone that they eventually found. But it's a very difficult locality. The bones aren't found articulated. They're scattered. They're very hard to find. You find isolated elements, and you find maybe 2 or 3 every field season because you can't sit and systematically work it because you're always chasing or being chased by the tides. So you can't just set camp and excavate. And also because the cliffs are 40, 50 feet tall, you can't actually quarry down to the fossil-bearing layers. So you're really basically taking whatever the ocean offers you from tide cycle to tide cycle. So they have accumulated, over the years, a number of different bones, and Bob would bring graduate students through to prepare 1 or 2 during their career to learn how to do preparation, to learn how to do specimen drawing. By the time I got to McGill, it had been 30 years, and he had accumulated a number of bones, and some of that final work that I had done on these Blue Beach fossils formed the basis of the chapter of a book that Bob and Jenny Clack published in the Hevel volume. But that's where my interest, picked up as Bob's career wound down. I took this project. I wanted to get these fossils into the primary literature, give formal descriptions to them, and that's what led to the project that we're talking about now. The paper that I published with Jenny and Tim Smithson and Chris Mansky at the Blue Beach Fossil Museum, and my former student Taryn Meyer.
So Blue Beach, of course, is a very significant locality because of its age, which is from a time generally known as Romer's Gap. Can you explain what Romer's Gap is and why it is so significant in tetrapods and general evolution?
Sure. Well, we have most of what we know from the Carboniferous come from later Carboniferous localities, classic places in North America like Greer in West Virginia, like East Kirkton in Scotland, where we have a fully formed terrestrial ecosystem. And not exactly the same as what we have in a modern trophic structure, but a good terrestrial ecosystem. And in the Upper Devonian, of course, we have the very first tetrapod fossils, which are very fish-like, and it's got a very progressive transition from fish to tetrapods. So that's that fin-to-limb transition. But the transition to land is hidden by this 30 million year gap between the Upper Devonian and these latter Carboniferous or latter early Carboniferous deposits, such as East Kirkton. That is what's known as Romer's Gap. And Romer lamented this gap because it was within this period of absence of evidence that in which he hypothesized all the interesting stuff in evolution of tetrapods took place. So Jenny Clack has been spearheading a project, an NERC funded effort to explore further Tornasian aged in particular. So that is the first portion of the Carboniferous after the end of the Devonian, looking at localities that have been recently discovered in Scotland and the Scottish border region of England, as well revisiting places in North America such as Blue Beach. Now, Blue Beach, based upon invertebrate and spore data, is placed slightly younger than some of these Scottish localities, so at what is known as the TN2, TN3 stages of the Tornasian. So it's the oldest known tetrapod-bearing fossil locality within Romer's Gap. So it really is a critical time period to investigate the evolution of tetrapods.
And what kind of tetrapods have you found from there so far?
Well, it's interesting. As I said, it's a difficult locality to explore because the fossils are disarticulated. And it has really taken finds of specimens around the world over the past 10, 20 years, including Peterpies from another locality in Scotland that Jenny Clack had described, and Wacheria, described by John Bolt and Eric Lombard from Delta, Iowa. So learning about the anatomy of what are known as Wacheriid animals has been critical to interpret some of the elements. Other elements, so we have clear evidence of one of these Wacheriid type tetrapods, so something that is known from slightly later in the Carboniferous. And we also have clear evidence of animals known as umballonirs, which are, again, they occur in these latter Carboniferous localities such as Greer, like Proterodrynus as being an example of that. But also, excitingly, there are elements, isolated elements that have very strong connections with fossils otherwise known from the Upper Devonian, things like Ichthyostega and Acanthostega. So what Blue Beach has enabled us to do, it has given us a window into Romer's Gap. And what this window is showing us is that, well, we're not necessarily getting clear evidence of that transition to terrestriality. What instead we seem to be getting is a smearing of what are considered to be latter Carboniferous faunas into Upper Devonian faunas. So we have like relics of the Devonian into the Carboniferous. So we seem to have a transitional fauna at Blue Beach, which is really very exciting.
When you talk about it being fragmentary, what kind of scale are we looking at? Like, are you just getting, half of a bone, or are you getting kind of half a skeleton?
Right.
How do you sort that out?
Right. So what we're mostly finding, we do find, half a bone here and there. What we mostly find are isolated, single, solitary bones. But they generally are pretty well preserved, each one. Some of them show more evidence of having been eroded after death, pre-deposition, because this is a high-energy, near-shore kind of beach depositional environment. So animals die, they wash ashore, they get pounded by the waves, they get disarticulated. And because it's high energy, it preferentially winnows away lighter elements, flatter elements. Skull elements, for instance, get winnowed away. And what remains are heavier elements. So we're talking about limb bones, sometimes pelvic girdle bones, very rarely vertebrae. And extremely rarely do we find skull elements. So we're really basing our interpretations in our paper based upon elements of the appendicular skeleton.
Do you have enough material to be able to name any of these, or just say they're from a general group?
Well, we could name them. It would be unlikely that those names would have any permanence.
Okay.
What we can do, we can't really identify them beyond sort of a family level, or even a slightly higher level than that, with any degree of certainty. What we can say about the Watcheriid is that it is more similar to Peterpes and another early Watcheriid from Australia known as Ocenodus, rather than the more derived, later occurring Watcheria from Delta, Iowa. So, we're getting some idea of the relative degree of relationships. For instance, the Embalomere shares characteristics with Proterogerynus, but also shares characteristics with a specimen from Scotland known as Eoherpeton, which also shares characteristics of even more primitive animals into the Upper Devonian. So, are we seeing this mix of features because this is an animal that has a mosaic of different characters from different types of embalomeres, or are we getting elements from different animals that are kind of mixing together? We can't say. So we decided to take a conservative approach and just say, to a certain degree, we know that this higher level of taxa were present, but it's a fairly diverse group. I mean, we've identified about 5 different types of tetrapods that were present.
Is that similar to the other localities like in East Kirkton or these kind of things? Do they have the same diversity of taxa in other similarly aged localities?
Well, East Kirkton is a particularly well represented locality, and where East Kirkton differs from Blue Beach. So yes, we do get a similar assemblage or similar number of taxa. In fact, East Kirkton is greater diversity because it preserves the smaller animals because it's not a high energy environment. We know at Blue Beach that there were smaller animals there. We don't have the hard part anatomy to prove it. We only know this through the footprints. So we know that there's more to be found. But you don't have the same assemblage. You don't have that same overlapping of Carboniferous and Devonian fauna. So the Devonian element of the fauna has dropped off by the time we get to East Kirkton.
And you might have mentioned this, but I've completely blanked. What was the environment like at the time of deposition? So I know it's going from marine to terrestrial, but are we looking at, you said high energy,
yes.
So is it?
So it's a beach environment.
Yeah.
It's been previously interpreted as a freshwater lake, but there are clear signs of a marine influence to some degree or another. And the portion of what is known as the Horton Bluff Formation, immediately lying below, is a really large evaporite sequence. So we know that there is a major marine involvement within the overall strata. So that's what I'm saying. We know that at different horizons within the exposure at Blue Beach, we have subaerially exposed sediments as well. We have, as I said, we've got trees in a forest. We have mud cracks, so we know that when we're near shore, sometimes we are shore, sometimes we're just offshore, and that water level, it rises and falls. Depending on where you are through the sequence. And we do find tetrapods in various different parts. So there are more classical marine black shales within this sequence. And we have found tetrapod bones there, even though predominantly as fish fossils in those deposits. So beach, high energy because it's, where the waves are crashing on shore. We have some surge deposits in rip clasts, storm rip clasts.
And what other material comes out of Blue Beach other than, we talked a little bit about there being the forests and that kind of thing, but is there a lot of invertebrates or other stuff that comes from there as well?
There are some invertebrates. You certainly find ostracods by the boatload. That's one of the reasons why we've been able to date as we have. Various megaspores are present, very rich. Some of the richest fossils from the area are rhizodont fish. So these are the deeper portions of the depositional sequence. Large rhizodont fish. Martin Brazo has described some of that. There are also various acanthodons. There are other early actinopterygians as well. In fact, I have an honors student who's finishing up a project on a brain case of an early actinopterygian.
Okay. And you said there's some large fish, but what kind of size of the tetrapods are they? Are these small-ish or big-ish?
These are generally large, because it's high energy. It filters out the. So these are animals that would be on the order of 1 to 2 meters probably in total length. Yeah,
I was just thinking. I know you mentioned that the small ones had been sort of filtered out, but it's sort of, I guess, an idea of what is small and what is large.
Sure.
So,
and there are footprint traces that previously have been attributed to tetrapods that are probably related to scuff marks from the forelimbs of a rhizodont fish. Now, rhizodont fish are the lobefin fishes, right? Yeah. They are extremely large. The head of the humerus, right now I'm holding up my hand and making a shape that's about 2 inches in diameter. They have a beautiful ball and socket joint at the glenohumeral joint.
Interesting.
And so these are really big animals, and they have huge scuff marks that they have left in the trackley fossil record.
So I guess, Blue Beach is kind of becoming more of a big deal recently, and you said that a lot of that is because material had been found before but hadn't really we didn't really understand what it was. And is it just because of these finds, or are people just suddenly realizing why it's so important, or has it just been too difficult to work in the past?
Well, it's been difficult for we professional paleontologists to work there because we don't live in Windsor. There's no major university in this particular area. You'd have to drive down to Dalhousie University or St. Mary's in Halifax, and there haven't been vertebrate paleontologists working there traditionally. But one of the major critical, tipping points in this locality was the formation of the Blue Beach Fossil Museum by dedicated amateurs, Chris Mansky and Sonia Wood, who actually live at the site. And walking the beach every day, seeing what each tide turns over, has enabled them to accumulate an incredible, enormous range of new fossils. And in fact, for the first time, we're getting associated elements of, for instance, a left and a right femur together along with a tibia, all actually from the same animal. This is the first time that we've had associated elements like that. Furthermore, because the Blue Beach Fossil Museum are located on site, a lot of the neighbors living along the beach have also used this as a focal point to donate their own personal collections, because you start accumulating things, and these rocks are big and they're heavy, and who wants to move them? So a lot of local collectors have donated their collections to this growing collection, and it is literally tons and tons of material that Chris has pulled off the beach, including full trackways and new fossils. So when I went there for the first time in the early 2000s, I had no idea that they were there, so we started doing our classical prospecting, found their collection, and realized that, we had hit the mother lode, so to speak, and it's formed the basis of a good collaborative relationship with these citizen scientists. So now we have published with Chris. Chris has also published on some of the trackway work with trackway workers, and it's really given us much more accessible data. So in combination with finding more complete fossils elsewhere, the new diversity of new finds, instead of just the relatively few elements that Don Baird and Bob Carroll had accumulated, it gives us tremendous comparative material. We can start saying something about numbers of different taxa present.
And do you have any new things coming up soon you can give any hints into, or any new interesting finds? Well, as I mentioned briefly, the new brain case of the actinopterygian, which is being worked on, finalized by an honor student who's hoping to get into graduate school himself. But what's exciting about that is the brain case is much more similar to what you see in late Devonian occurring fish, rather than in more derived Carboniferous fish, which is really exciting, because at the end of the Devonian, there's hypothesized a major mass extinction. What the tetrapod fossils seem to be suggesting, though, is that we've got the smearing of different fauna. So it appears that the tetrapods may not have been strongly affected by this mass extinction. And now with this brain case, it is suggesting that maybe the fish haven't, at least that group of fish, made it through the extinction relatively unscathed too, because it is an upper Devonian form. Now, what ended at that point are placoderms and things like that. We haven't found any evidence of that into the Carboniferous. So that portion of the extinction still stands. But it seems as though that mass extinction is much more nuanced than we first thought, because of this huge hiatus in the fossil record. And of course, we have actually proven that this is a hiatus in the fossil record, rather than being caused by any sort of external factors, which were previously hypothesized. Say there were no fossils found at this time because it was a global low oxygen level, and perhaps that had put a dampening effect on the evolution of tetrapods. So we've said, no, well, it's a failure of collection, of a failure on our part to find deposits at the right time and collect fossils. And this is really being driven home by the fossils that Jenny and Tim are working on from the Scottish Borders region, where they're finding a very rich deposit of tetrapods, and actually much better articulated as well. So the story is going to be much more thoroughly developed from their finds. But we're hoping to go back to Blue Beach, and we want to better characterize what else is there. I'd like to nail down, the morphology of this rhizodont fin, because there's some question of whether one of the tetrapods we've identified might not have been incorrectly an element of one of the rhizodonts rather than a tetrapod humerus. I think that we've got it correct, but double checking these sorts of things and testing ourselves is the hallmark of science, right? Yeah. Is there anywhere else in the world that you could look for this kind of age? I mean, there's obviously in Scotland they are actively looking,
right? But
are there really only two places that you can find this material? Or
there aren't a lot of deposits from this particular time. There is another locality that was originally worked by Romer in the eastern United States that Stephanie Pierce is relocating, and so hopefully she will be finding more efforts. This is part of this whole project. It's called the TWEED project that's headed up by Jenny. So hopefully Stephanie and the Harvard crew will have great success at their locality. And hopefully podcasts like this will get scientists from elsewhere around the world thinking about the Tornesian and looking in these deposits and seeing what else we can find.
Yeah, because it's such an important time for tetrapod evolution and for what's going on just in the world, like terrestrial ecosystems, that it's crazy to think there's only 2 or 3 localities in the world. Like there's got to be more. We have to be able to find more.
Well, I find it's actually analogous to the earliest Triassic, I think, in terms of marine reptiles, which is I've had students working on ichthyopterygians. And the earliest Triassic, you've got the wonderful deposits in China. You have fantastic deposits in British Columbia, and then fossils in Spitsbergen, and not a whole lot else globally. It's so it's that contingent factor. The geologic process reworks fossils, reworks deposits, and sometimes you have more exposure than others.
Well, I think Blue Beach is a really exciting place, and I think this is an exciting time, and thank you for talking to us about it.
Thank you for having me on.
Paleocast was brought to you by Dave Marshall, with Joe Keating, Laura Soul, Liz Martin-Silverstone and Caitlin Colery. It was made possible by funding from the Paleontological Society and the Paleontological Association, but the show now relies on contributions from you, the listeners. If you've liked this episode, please consider donating, and thanks to everyone that's helped out so far. We'd also like to thank the Ocean Collective for use of their music. Please visit paleocast.com for the supplementary material to this episode and for our archive of past programmes. Subscribe to our Twitter feed @Paleocast and like us at facebook.com/Paleocast to get all the latest news.